Hello children, welcome to this mathematics session. In this session, we are going to learn a concept, Euclid division algorithm. This is one of the most important concepts of our 10th class mathematics, which is in first chapter. So we're going to learn it. So observe carefully, stay focused. Right, for this, suppose three people went to market to buy something like fish. Suppose they found these fishes, count them, you will find 12 fishes are there, right? Say 3, 6, 9, 12 fishes, yes. So they want to buy them and share equally. So you can guess that how many each one can get. Yes, of course. So each one can get 4 each, right? Right. So there are 12 fishes and 3 people went to buy. So 12 is equal to 3/4 and nothing left. So that's what I want to write in this manner. 12 is equal to 3 into 4 and nothing left, 0. So here I have already 12 and 3, but I found new numbers 4 and 0. Keep in mind, suppose if there are 13 fishes like this and the same 3 persons want to share equally, so what could be the sharing? Of course, each one get 4 again, but one will be remaining. So that's what I want to write. 13. There are 13 fishes. 13 is equal to 3/4, again 4s, but 1 left this time. So how can I express this? 13 is equal to 3 into 4 plus 1 this time. This is the remaining one. So understand this remaining one, that means the one fish that had been left is less than the people. Of course, if 2 also there, it is also less than the people. 2 fishes are there. If 3 fishes remain, again they'll share each one. So this the fish that remained, that had been left, is the number 1 is less than these people 3. So let me make you more clear about it. Now let's jump into the actual concept. Suppose take any two positive integers, 12 and 4. See this relation, 12 is equal to 4 3s, obviously. So 4 3s are, we can write it as 4 3 plus 0. 4 3s plus 0, nothing left. So how many 4s are there in this 12? How many 4s are there? 3 4s are there. Of course 3, right? So there is a pair of integers 3 and 0. See, already we have 12 and 4. We are trying to connect them. 12 is equal to 4 3s plus 0. There is a pair of integers 3 and 0 which connects 12 and 4. 12 and 4 have been connected by these integers 3 and 0. Try to understand. I'll give you more examples. So are there any pair of positive integers that connect 12 and 4 in such a manner? Can you tell any pair of integers that connect 12 and 4 in this manner? In this manner, in the sense, of course, I can connect like this, sir. 12 is equal to 4 2s, 8 plus 4. But the number left here, see, the number left here must be less than this number. That's why I want to choose like this. 12 is equal to 4 3s plus 0. Now this time this 0 is obviously less than this 4. Okay. I don't want to confuse you more. Let me take one more example. So obviously I tell that there are no such integers that can connect 12 and 4 in this manner. That means there is a unique pair of integers 3 and 0 such that 12 is equal to 4 into 3 plus 0. So the thing that remained must be less than the smaller number here, 4. So that's why this 0, either nothing should be left or must be less than this 4. Okay, let me take one more example so that you can get clarity. Example 2. Now take any positive integers 13 and 3, right? How can you connect these both these as first example? of course you're trying to connect them. 13 equal to okay, anyway, how many 3's are there in 13? How many 3's are in 13? How many 3's can be obtained from 13? 4 3's. 4 3's. 3 3 3 3 3 4 3's becomes 12 and 1 will remain. So 13 equal to 3 times 4, I mean 4 times 3 plus 1. So 13 is equal to 3 into 4 plus 1. So this 4 and 1 are connecting 13 and 3. Mind you, the thing that left here, 1 reminder, that's what has been left is must be less than this 3, this particular 3. You can connect 13 and 3 in different ways. 3 2's are 6 plus you can write 7. But the number here 7 must be the number here must be less than this number 3. But it is 7, so much big. That's why what should be the syntax here? 13 equal to 3/4, then plus 1. Then only you will get the number less than this. Is there any way you can get like that? So that's what you can understand. There is a pair of integers 4 and 1. See here we took 13 and 3 and we are introducing 4 and 1. There is a pair of integers 4 and 1 which connects 13 and 3. 13 equal to 3 into 4 plus 1. Are there any pair of positive integers that connect 13 and 3 as above? Can you find one more pair like that? You cannot. Obviously no. That's why there is a unique pair of integers 4 and 1 such that 13 equal to, see now you can understand this, 13 equal to 3/4 plus 1. And this 1, the thing that had been that had been left is either 0 or must be less than 3. That's why 1 is obviously less than 3. Sometimes you get 0, nothing will left sometimes. Sometimes something will left, but the thing that had been left must be less than this particular number. You will understand in the due course of time. I'm not using the exact words. Okay, for the final confirmation, let me take one more example. Suppose 146 and 14 have been taken. Now how can we connect these? You can do 146 is equal to 14 tenths, because you have to use 14 here. 14 tenths plus 6. This 6 is clearly less than 14. That's what we have to understand, this particular syntax. There is a pair of integers 10 and 6. We introduce 10 and 6 now. Don't worry, see, 10 and 6 we introduced. We took 146 14. So 146 is equal to 14 tenths plus 6. So there is a pair of integers 10 and 6 which connects 146 and 14. Are there any such pair? I use the word such pair. Such pair in the sense that thing that left must be less than this 14. Obviously no. That's why we use the word unique pair of integers. These pair, what is that pair? 10 and 6. This pair is unique, such that 146 is equal to 14 tenths plus 6. Here 6 is not 0, of course. That's why it's more than 0 and less than the 14, less than 14. I think now you understood these relations. Okay, let me deal with differently. Now take integers 23 and 5 this time, okay? 23 and 5. Suppose 23 is dividend and 5 is divisor, right? You heard about these things, dividend and divisor, right? In division we use dividend and divisor. Divisor means, okay, you have this side divisor, this is dd, okay, and you will be having quotient and something you will have here and something will be remaining. So these all words relate to divisor. So suppose 23 is dividend and 5 is divisor. Here it is, 5 4s are 20 and you have 3 as remainder. So how can we connect this 23? This is the main one, of course. So 23 is equal to 5 fours, we multiply these things, 5 fours of course, plus the remaining one, that means 20 plus 3, 23. Likewise we connect 5 fours plus 3. Indeed, but the thing left with the remainder is always less than the divisor, right? This 3, either sometimes we get 0 as remainder, or but whatever we get as remainder must be less than this particular division, right? That's what here I wrote here. Either we get remainder 0 or equal to, or the remainder what we get must be less than the divisor. This is what this particular statement means. So of course, how did we learn it? It is division fact. Division fact. We used this word, particular word, division fact. Indeed, almost. I want to correlate the things that we learned previously and our actual division. Now let me come to the point. Suppose A is dividend. Suppose A is dividend and B is divisor. Okay, right? A is dividend, main one. A is dividend and B is a divisor. Okay, and here we will get Q and you will get R. That's what I'm going to show you. The same thing. So how can we relate all these things? This particular A, the main thing, is equal to B into Q plus we add this remainder. A is equal to B into Q plus R. What about the remainder? What is the nature of the remainder? Either it becomes 0 or more than 0, but it must be less than the divisor B. So this has been learned as division fact for us. So it runs on the similar lines, these Euclid division lemma. See here, given now, suppose if we take positive integers A and B, suppose you take two numbers A and B, there exists a unique pair of integers Q and R. We are introducing two numbers Q and R, satisfying A is equal to BQ plus R. This is the condition where R, the remainder, is either 0 or less than the divisor. This is what popularly known as Euclid division lemma. Okay, let me state, given positive integers, suppose take two positive integers, we took 3 or 4 examples, A and B, and we got two more, those are Q and R. How? So given positive integers A and B, there exists a unique pair of integers Q and R satisfying A is equal to BQ plus R along with 0 less than or equal to R less than B. This is known as Euclid division lemma. So what do we do with it? What do we do with Euclid division lemma or Euclid division algorithm, also known as algorithm? What are these words, lemma, algorithm? I will explain you at the end of the session, okay? Now, what do we do with this Euclid division lemma? Right, we find HCF of two given integers. We can find HCF of two given integers. It is our domain, of course. We may have different implications, but here we are going to find HCF of two given integers. How? This, suppose find HCF of 116 using Euclid division algorithm or Euclid division lemma. Right, find HCF of 60 and 100. Right, how do we find? Right, here see, we have two integers here, positive integers of course, and we bring two unique integers. How? Yes, 100 equal to 61 plus 40. So these are the unique integers. We brought 1 and 40. And again, what we do, see 60. We use this particular thing. 60 is equal to 41 plus 20. Right? 41 plus 20. Here again we bring 1 and 20. Again 40 equal to 22 plus 0. Understand these three steps, you can understand. I'll show you the normal method, how we used to do here see this division. Now you can understand 61s are 60, or we are going to have 40 as the remainder, and again we bring this 60 here. That's what we did here. 41s are 40, So 41s are 40. We are going to have 20 as a reminder. Again we bring 40 here. 22s are 40. So this is the way these three steps, and in fact we may have some more steps, but here these three steps are the way we can do or we can find HCF of two numbers. See, 61s are 60 plus 40, and we use every time we use this one 60. So 60 is equal to 41s are 40 plus 20, and this 40 we can use. Now you understand with one more example, right? Let me, so the HCF of 60 and 100 is 20, right? Is it clear? So the biggest number that divide both 60 and 100 is 20, isn't it? 23s, 25s. You never find a bigger number than 20 which can divide both. 20 is the biggest number, highest number. That's what HCF means. Okay, now find HCF of 900 and 270. So how will you start? In fact, yes, you understand, 900 equal to 273. Almost it becomes 810 plus 90. Okay, 274s will become bigger. That's why 273s. Now what will we take? Yes, this one, 270. You understood rightly. 9, and we use this 90. 93 plus 0. Over. Finish. As soon as we get remainder 0, our division is over. That's why the last thing, the last divisor will be the HCF of the given numbers. That's what. So 900 and 270 is HCF is 90. Right? So this is the way how to find HCF of two numbers. You can find using your textbook examples, right? But let me finish this session with explaining some of the keywords. Algorithm, Euclid division algorithm. Algorithm means a process or set of rules to be followed, or a step-by-step ordered procedure. Algorithm means, that means so whenever our mom or someone else is cooking, they follow step-by-step procedure. They follow a nice procedure to get a delicious food, right? So the recipe that they would follow will give us beauty to that particular food. So algorithm means step-by-step ordered procedure. And one more word you heard, lemma. What is lemma? It is a minor or small proven result. It's a small result which may be used for other large results. So you understand all these things when in the due course of the time, when you grow up, you understand these lemmas, theorems, algorithms, everything. But here lemma means it's a small statement, proved statement. Okay, so no confusion. And let me show you finally the boss, Euclid. He is really father of geometry. He collected so many books and named and written under the heading the elements. You might have learned all these things in your 9th class. Study about him, watch about his history. Is really a great man of mathematics, right? Good. So today we have learned about Euclid division lemma, and what do we do with it? We find HCF of two numbers in a particular manner, in a particular algorithm, and we use a particular syntax for that. So watch it time and again so that you learn better. Bye. Thank you. This is Vinay, your mathematics teacher.